Today I'm going to discuss about digital logic gates. So the basic important thing is why should I learn the digital logic gates? So what is the importance of digital logic gates? So with the help of digital logic gates, how to implement the combination circuit sequencing we will see in the coming lectures. Let's see digital logic gates. So to construct any computers like a digital systems, the basic building blocks is digital logic gates only. Okay. Let's see. As you know, these systems are like laptops, like computers, cameras, mobile phones, all this. Which systems are run on zeros and ones? That systems are nothing but digital systems only, because these systems only knows about zeros and ones. So, how to implement the basic building blocks of digital systems? So, I have given one example. If you construct a house, what is the basic building block? So bricks are basic building blocks. Same way to construct any systems like a digital systems, the basic building blocks are only digital logic gates. So we have 7 types of logic gates are available. So which are 7 gates. Out of 7 gates, 3 are basic gates, 2 are universal gates, 2 are special gates. So why 3 are universal gates? Why 2 are universal gates? Why 2 are special gates? See, I will explain everything in a clear manner. So just follow my video. And here, out of 7, 3 basic operations requires 3 basic gates. 3 basic operations requires 3 basic gates. The basic operations are multiplication. And next one is addition. Next one is complement. That means not operation. So multiplication is nothing but same as multiplication in the digital in our real life also as in the mathematics. So addition, this is same in the normal addition process. This next one is complement. So for making the multiplication logic, we require that one gate. That AND gate is called as AND gate. So to get that addition logic, we require the one gate which is called as OR gate. So to get the complement, we require one gate which is called as NOT gate. Okay, fine. Let's come to that. So 2 are universal gates. Why these 2 are universal gates? So to implement any gates like basic gates and special gates uh, by realization of NAND and NOR only. That's why these 2 are universal gates. I have given a simple analogy. So if you know English, you can survive in any place in the universe, in the world. Same way, if you want to implement any type of gates, so only the NAND and NOR is possible. That's why NAND and NOR gates are universal gates. And there is one more important thing is these gates are available in the hardware of the IC. Okay, so here that next 2 gates are nothing but special gates. 2 special gates. These 2 special gates are called as XOR and XNOR. So these 2 gates are will help you to detect any mismatching of 2 inputs, mismatch or match of 2 inputs. Okay, so these two XOR and XNOR gates will be used in the communication itself. Two inputs. Okay, I'll discuss one by one. Let's see. The first gate is AND gate. As I told you, the AND gate is used for to implement multiplication. Okay, So it has number of inputs, any gate, number of inputs, only it has single output. That means n number of inputs, but only having the single output. This is the standard for rule for implementation of logic gates. Let I am taking the two input AND gate. It has two inputs. Let I denote that A, B are inputs, and it has only single output Y. Let us draw the symbol of AND gate. This is the symbol of AND gate. It has two inputs A, B, and output is Y. So Y is nothing but A multiplication B. So that's why multiplication of A and B, that is assigned to Y. So after that, we need to know what is the relationship between the inputs and outputs. So that we can define in one table which is called as truth table. So here that, so this is called truth table, a table which tells about the truth for your inputs and also outputs. I'm giving the two inputs 0, 0, 0, 1, 1, 0, 1, 1. Okay. So tell me about that. What is that A into B? Let us calculate. 0 into 0 is 0. 0 into 1 is 0. 0 into 0 is 0. Next, so 1 into 1, obviously what is 1 into 1? So 1 into 1 obviously is nothing but 1 only. Why 1? So if any one of the input is 0 means in normal multiplication also 0 into 5, 0 only. The 5 into 0, 0 only. And 0 into 0, 0 only. When you are getting the non-zero value, so the two numbers are non-zero, it may be the non-zero value. Same principle apply over here. So this is the case of AND gate logic. When both inputs are 1, output is 1. And next, we can see that OR gate logic. So the same as OR gate. OR gate has different symbols. OR gate has different truth tables. I have to explain OR gate. OR gate. It can be used to design for the addition operation. So I have taken the two inputs A, B, and I have taken the one output Y. So let I draw the symbol of OR gate. This is the symbol of OR gate. So please remember this symbols. AND gate symbol, OR gate symbol, both are different. Y is equal to A plus B. So next one is, then come to here. So truth table, so means the relationship between inputs and outputs. So I have taken that A, B are inputs, Y is output. I am taking the 0, 0, 0, 1, 1, 0, 1, 1. So what is output of this one? So 0, 0 is 0 plus 0 is 0 only. 0 plus 1 is 1 only. 1 plus 0, 1, 1. So that means if any one of the input is 1, obviously output is 1. That is the OR gate logic. Then Y equal to A plus B. Then I had to explain the NOT gate. NAT gate is designed for complement operation like inversion. Suppose we are given the 0 as input, we will get the output as 1. This means always complement to each other. So if I give the 1 as input, output is 0. If you want to get this type of operation, so we go for NOT gate. The symbol is, this is the NOT gate symbol. It has only single input, single output. I am taking the truth table of NOT gate. A is input and Y is output. I have given the 0, output is 1, 1, 0. This means, you see, I have given the input is 0, output is 1. Given the 1 is input, output is 0. So this is the advantage of inversion. Sometimes we are calling as a complement gate. Complement gate. Let's see that two are universal gates, I told you, right? So NAND and NOR. So this is the gate which is combined two gates. The first one is AND gate. Next one is NOT gate. So AND and NOT. The symbols also same way. Take a one AND gate symbol. Okay. This should be combined with NOT gate. So the combined symbol is nothing but, this is nothing but NAND symbol. I am taking that A, B are inputs, Y is output. So the operation of this one is nothing but up to now I am given the A and B over here. This is called as A into B. This A into B is given as input of the is one input. Okay, input of the NOT gate, it becomes A into B whole bar. The same way A into B whole bar. To take a truth table, it has two inputs 0 0 0 1 1 0 1 1. So it is not gate NAND gate, right? The exact opposite of AND gate 0. That means if both input is 1, output is 1 in the AND gate. But here the both input is 1, output is 0 in the NAND gate. Let's come to the next gate is NOR gate. So it is also combination of OR plus NOT. You can take like this. OR is like this, NOT is like this. Okay. I am taking the inputs are A, B, which is the output of A plus B. The A plus B given as single input, and it is the output is A plus B whole bar. So this is finally output Y. The combined symbol is take a OR gate. Along with that, you can insert the bubble A, B, the Y equal to A plus B whole bar. Then come to the truth table. It has two inputs. Not only about two inputs, it is not limiting two inputs. You can give any inputs, number of inputs 0 0 0 1 1 0 1 1. As you know, right? Opposite of the OR. So means 1, the remaining all are zeros 1. Next one is the very important gates are in the logic gates are universal gates. So first one is XOR. It is the exclusive OR gate. Exclusive OR gate. So means when two inputs are different, output is 1. If two inputs are same, output is 0. This is the logic. Okay. So the expression for this exclusive OR is A bar into B plus A into B bar. This is both inputs are, this is input is different, this input is different. But this is nothing but negation. This is 0, this is about 1. Okay, 0, 1. What is 0 complement? Obviously, 0 complement is 0. Okay, if it take the A is 1 means 1 complement is 0. Okay, so then symbol is that it is the exclusive OR symbol. It has two inputs A, B, Y. So Y equal to A exclusive or B. You may write like this. Okay. It has the truth table is it has two inputs A, B. I have taken the four combination 0 0 0 1 1 0 1 1. That I am taking that 0 0 0 0 means if two inputs are same, output is also 0. If two inputs are different, output is 1. The logic you need to follow over here. So here that see two inputs are different, output is 1. If the two inputs are different, output is 1. Two inputs are same, output is 0. This is the exclusive OR gate. The next gate is XNOR gate, which is the last gate in the digital logic gates, XNOR gate. So this NOR gate is opposite of exclusive OR. Okay, that means when two inputs are same, equal, or same or equal, then output is 1. So the expression for the exclusive OR is same, and both A and B are next or A bar B bar. Okay, this is the expression for. Let's draw that symbol. So the exact opposite of the exclusive OR. So just want to be attached double. So same as it is like a XOR plus NOT gate, and take that A input and output Y equal to same expression. So take that truth table. It has two inputs AB and output is Y. I'm taking the 0 0 0 1 1 0. Let's observe. Okay, let's observe. So I have taken the two inputs. First combination is 0 0. Same 1 0 1 different 1 0 different 1 1 same. So this way same inputs output is 1. Okay, this is the exclusive NOR. So till now we have discussed about all logic gates and importance of logic gates, and the logic gates applications are nothing but all digital circuits. Digital circuits are used to implement the digital systems. So thank you. We will catch up in the next video.